I welcome you to this 10th Doctoral Symposium. This symposium has the particularity that it is starting for the first time, I believe, with a session on engineering research. This is why I am here. So I'm chairing the session. It is with great pleasure that I'm chairing the session. The keynote speaker for this session is Professor Hamid Al-Raweshidy, who is the director of the Wireless Network and Communication Center at Brunel University. If you allow me, I will give a brief introduction of Professor Hamid Al-Raweshidy before I give him the I invite him to come here and present his presentation. So Professor Hamid is a professor of communication engineering, and he's with the Department of Electronic and Electrical Engineering in the Engineering Design and Physical Science Engineering College at Brunel University. His brief, Professor Hamid holds a B.Eng and an MSc from University of Technology, Baghdad, a postgraduate diploma from Glasgow University, and a PhD from Strathclyde University in Glasgow. He was, before joining Brunel University, he was with the Space and Astronomy Research Center in Iraq, then Perkin-Elmer USA, Carl Zeiss Germany, British Telecom UK, Oxford University, and Manchester Metropolitan University, then Kent University. Correct me if I am wrong, Professor Hamid. And as I said, he is currently Director of Wireless Network Communication and also Director of Postgraduate Studies at Brunel University. Professor Hamid's research record is impressive, over about 400 papers in international journals and refereed conferences. He is the editor of the first book in radio over fiber technologies for mobile communication networks. He acted as guest editor for many international journals on wireless personal communication. He has some also industry experience, not some, a lot of industry experience. He currently acts as a consultant and is involved with projects with several companies and operators such as Vodafone, Ericsson, Andrew in USA, NEC in Japan, Nokia Finland, Siemens, Frank Telecom, Thales in Italy, and also Telmar in Italy. He is the principal investigator in the EPSR-C, which is the research body, Engineering and Physical Science Research Council, in UK, and he's the principal investigator in many projects at in UK, but also at the European level. He was a member of several international conference advisory committees, and technical program committees. So also he has been invited to deliver many research, many talks, etc. So the list is really very long and impressive, and I would rather spare time for Professor Hamid to give his very interesting presentation. So his presentation will be his current research. Before talking about the presentation, his current research, which is of great interest to the College of Engineering, is 5G and beyond, such as CRAN, Cloud and Centralized Radio Access Network. He's also his research is also in software-defined networking, IoT, machine-to-machine, and radio over fiber, technologies. His keynote speech will be on research in the computer, in electrical and computer engineering. He will spare some time, he will devote some time to speak about research in his center in general, but then he will focus about 20 minutes, hopefully, over the Masters in Wireless Communication Systems, which Ahlia is hoping to host, starting hopefully next September. So thank you. Join me to welcome Professor Hamid Al-Raweshidy, and I welcome Professor Hamid, to give his presentation. Thank you.
The title of my presentation today is Research Topic at Wireless Network and Communication Center, WNCC. Just to give you an idea about the, excuse me, I always try to Okay, I'll try to move a bit. Right. WNCC consists of more than 50 PhD students and research fellow and about 5 members of staff. And we deal with several issues where I'm going to talk about it. I will try to make it as simple as possible. I know some of you from different they have experience in different research topics, business or something else, but I will try to make it simple. Now, I'm going to talk about 2 things today. Mainly, I'm going to talk about research topic, and I'm going to explain to you why and what and how. And then I will come to the MSc Wireless Communication Networks course, and I'm going to talk about the different module in this MSc course, the aim of each module, hopefully, and the content generally. Why are we carrying research in such area in communication? Because now communication is totally different from maybe 10 years ago, and maybe everybody knows there is civil engineer, mechanical engineer, and even within electrical engineering, there is something like power system control. With communication, everything is different. Communication is very dynamic. If you read a paper or a book 2-3 years ago, I could assure you that when you read it today, a lot of things has been changed. And this is why I always ask my PhD researcher, don't trust anything on the Google or on the internet. Not because it's not right. It was right at a specific time, but not now. So I'm going to show you, this is the amount of information. I need to spend a bit of time here because this is very important for me. And this is something you could find it if you Google it. And you see that the amount of data per month in 2016 is 7 EB. And this is exabyte, 10 to 8 byte. Sorry, 10 to 18 byte per month. This is in 2016. Just look what happened in 2017. From 7 to 11. And then in 18, from 11 to 17. So this is about 4 extra, another 5, 6. And then from 17 to 24. And then from 24, look in 19, this is what they are expected. In 2020, there will be a jump, 35. Why? Because we are expecting everybody, I heard even in Bahrain there is some field trial, but definitely in UK we have more than one field trial. All the operators, they have field trial, and some of them they would like even to start early 2020. And in 21, 49. Now how we going to manage this amount of data? Imagine yourself, I have been told yesterday, this is, by the way, my first time I visit Bahrain, and I was astonished of everything, but I have been told that there are 2 roads, one vertical and one horizontal. If you assume that the capacity of this road is maybe 10,000 cars, what happens if it will be million cars? We need to find a solution. Now you tell me the solution. I don't know what's the solution. Either we go and walk, because Bahrain is not very large area, but if you go to somewhere else, then you can't walk with the distance, or you could use your bike, or in the summer you can't, I think it's very difficult, or you could have more than parallel highways, whatever. There are so many solutions which we are trying to do with it. So this is why, for one reason, if you look here, And this, you will see that how many devices, okay, available in 2021. This is the most important thing. If you look here, you will see that most of our data in 2021, even in 2020, is video. And this is, again, when we say video, it's totally different from voice. Voice data rate is so low, while the video, we need a huge data rate. And this is what I'm interested in. Now, whether this is correct or not, this is from Telefonica, okay? And this is what it's saying to us, that we communicate. So I don't know what's going to happen, to be honest, because now I see a lot, even I read articles that parents, children, they always think that parents, they use their mobile more than even contact their children. But this is why. Second thing, what are the research areas we are interested in? If you look here, in English you need to put "and" here. I haven't put "and" because there are so many other things. I don't want to, for example, we do channel modeling, something else. I don't want to put everything here, but those are the main thing, which is cloud radio access network, beamforming, which means, I'm going to explain it in a simple way. Beamforming, in a traditional way, we have an antenna, and the antenna transmits isotropically. It's like a circle. So everybody will get power. But why I need to do that? I'm wasting power. If I want to talk to Dr. Talal, I could have a beamforming, and then I transmit a signal. So I will reduce the interference, reduce power, and so on. I'm coming to this later on. We do massive MIMO. Instead of having 10 by 10 antenna, traditionally we have one transmitter or receiver. Then the things advance, we have massive MIMO, 10 by 10 or 20 by 20. And then we have something called massive MIMO, which means that we have 100 by 100, and I will show you what we are researching now. AI is something which is artificial intelligence. Now, you could see it everywhere. Intelligent, defense, traffic, autonomous vehicle, communication. Most of our work involved AI. And then we have something called millimeter wave. 5G using millimeter wave, but they use 20, 40, up to 60, some of them even 100. Now we started working from end of last year on a frequency which is 200, 400 gigahertz. And this is what we think it is a 6G. So most of our research, I could say even more, all of our research nowadays on either 5G beyond or 6G, okay? And then we do Prof, which is a combination between radio and fiber, because as you know, the internet, all the basic is fiber. And then we do quality of service and the quality of experience. The second part is IoT, Internet of Things. Now, this Internet of Things, maybe 10 years ago, they started working on it, but there is something new which is called IIoT, which is Industrial Internet of Things. And I could assure you, most of the industry soon will have IIoT, okay? A lot of industry started. Now, we published a paper recently in 2018, which is using I-IoT. Now, if I would call it IIoT, it would not make a difference. But I put I here, intelligent IoT, which means there is artificial intelligence in the IoT. We do some work on solar energy, which is, I'm going to show you some block diagrams. We do some work on cloudification with SDN, NFV. I haven't mentioned anything. As I said, I haven't put N because there are so many things. We work on sensor networks, machine-to-machine, autonomous vehicle, security, and protocols. I mean, I deliberately put some colors here. If you see that, different colors here. But then if you look here, those are the same color. Because one of the new students from your university, hopefully I wish that within this year he will be able to publish in IEEE. I will show you our publication. 99% of our publication in IEEE. Okay, because this is what we think the best place to publish our work. So I hope my new students going to work with IIoT, which is intelligent with big data and security. Okay, I know it is two heavy topics, but I think this is what we think is going to happen in the next future. So how we are carrying research? I'm going to give you example, and I'm going to skip some of the slide because I don't want to burden you with a lot of things. I'm going to skip any equation. I would like to make it simple so everybody in this room will be able to understand what we try to do in our research. And I want to concentrate as well on our MSc wireless communication. Now this is the base station. As you know, everybody, maybe all of you knows that when you have a mobile, you communicate, there is something called the base station. You transmit the signal to the base station, and the base station will send the signal to the receiver, and that's it, okay? This is as simple as possible, and all the complication is here, okay? Then, after a certain time, people thought that let us do something, that we put here just something simple, and then we have a fiber connected to something called BBU, which is baseband unit. All the processing will happen here rather than at this point, okay? But there is a problem with this, because if I assume there is a base station, then the distance to transmit, it could be 5 kilometers, 10 kilometers for one base station. So the power here will be huge. And this is, of course, it could affect the health. And I have done some work with Vodafone regarding the health here. But again, when you have something like that with 10 kilometers or 5 kilometers, you're going to reduce capacity. Capacity means number of users, how much data you could transmit, how many cars you could draw these cars, you drive the cars in a road. Now, there is a way to increase the capacity. One of them is bandwidth. The bandwidth you buy it from the government. Now, this is a national, okay, security issue, okay? And this is very, very expensive. I give you an example. In UK, we have in 2001, the operators in UK paid for a very small part of the bandwidth, $44 billion for a very small piece of bandwidth. So it is very expensive. And most of the bandwidth has been occupied either by military, by something else, TV, health, whatever. So what we start thinking is to have something called RRH, which is remote radio head. So small things, just an antenna and a converter with amplifier. So this will be cheap, maybe cost you £300-400, and then you transmit the signal via fiber and all the processing happening here, okay? And this is here what we have done, and I will show you what we have done into more details maybe in the next few slides. Just to give you an idea about the power which we dissipate in the base station. The power consumption in the cell side is 72%. From this 72%, 46 for air conditioning is nothing to do with our communication. It's only for air conditioning. So we need to minimize this. How to do to minimize it? To make a simple and very small base station, what we call it RRH, remote radio head, to be able to minimize the power. And this is how we have this large cell, and then a smaller cell, and a 3G, UMTS, and then LTE, more cells, and in 5G we'll have more and more cells. I don't want to repeat this. This is what's happening, and this is what we are now investigating. Okay? I mean, we've already done this. You see here, this is a very simple antenna, and then amplifier, and then this is the fiber, and then there is something here to control. We went more further step more, and by allocating those BBU, all those BBU have all the hardware and software. Now, what we need to say, each one of those, say this will be able to have a capacity of 1,000 user, and this one 1,000 user, and this one 1,000 user. Okay? Now, each one of those will be allocated by one BBU. What happens if there are 200 users here and there is 0 user here? This will operate, and this one will have a blockage of 100 users. So we need to do a balance, and this is what we are having done in this area, and by using this kind of technology, we have been able to reduce the power consumption, and we have been able to reduce the cost. And I will skip this, but give you an example. There are so many BBU, hardware and software, and each one of those responsible about those RRH. If we keep it like this, as I said, if we have users here more than what we expected to deal with, then we will not be able to serve them. What we have done, we said, okay, let us make all those 3 RRH belong to this one, and this one belong to this one, and this one belong to this one, which means that we will not have a blockage of users. And we have used different technology here, like genetic algorithm, swarm intelligent artificial neural network, and so on. I'm not going to go into details. We have implemented something called SUN, which is self-organizing network, by switching those to 3, 4, 5 BBU for each of this. And this is a simple example. I am sure everybody will understand this dead easy. Imagine we have BBU1, the green, yellow, and then you see this, each one of those will have a capacity of 20 users. If you look here, the green one will have 30, which means we will have 10 users here, and this only will be blocked. And in yellow one as well, we have 1, so in total we have 11. If we do our artificial intelligence, and I'm going to say, let me have BBU allocated to those RH1 and RH3, and this one here, RH2 and 4, 2020, so I don't have any blockage. Only in the yellow one, I have 1. So I have 1 user blocked. Here I have 11 users blocked. And this is what we have done in Shiraa. And this is again something which is 5G and beyond. They haven't used it in 5G now, but what we try to do is make something which is called cell densification. Divide the cell into more and more cells. Thus, although this is a small cell, we're going to divide it to more and more smaller cells, and we transmit a millimeter wave. Okay, and I will give you some indication why a millimeter wave. If you look here, you will see that this one here has been using artificial intelligence, which is this one. I don't want to go into details. This is a bit complicated here. But this work has been published in IEEE transaction on network and service management in 2017. If you look at the point where we have been able even to try to sectorize it in our appropriate way, again, we will be able to minimize the blockage. And this is very important. We don't want any user to be stopped from transmitting the signal. Again, this work has been published in IEEE transaction on network and service management in 2018. This is here how to try to have a self-organizing network, which is called cell densification and integration. So we densify a cell and then we integrate the cell. And this is how we do it. We have this cell, we divide it to small cells we try to use in the edge millimeter wave, and then we sectorize it to more levels here. And this is how we will be able to increase our capacity. Again, this work has been published in IEEE transaction on network science and engineering in 2017. Right, I need to skip all this. The second one is using a millimeter wave. This work has been published in optical engineering. It's using 64 gigahertz, and we have been generating this 60 because you need to generate such a high frequency using the fiber. And there are two ways: either you transmit the signal fully by fiber, or you could transmit it using what we call it free space optics. This is a millimeter wave with massive MIMO and beam forming with artificial intelligence for 6G networks. This work has been started late 2018. I have a PhD student working on this, and this will show you. I think this is good in Bahrain because you don't have, like in UK or some other country, you don't have snow, heavy rain, and so on. And this will show you the characteristic of the behavior of the signal when you transmit the signal. What will happen when you have O2, when you have water, and when we have a light rain. And if you look here, we are interested in this range because this is the lowest. Although always the frequency, because as you increase the frequency, you're going to increase attenuation. But there are a lot of things which is related. In the radio frequency, rain and all those will not have a severe effect. But when you go to a millimeter wave, then this is the problem. Rain will have a huge effect, and oxygen and everything. And this is the system now. My PhD student working on it. And if you look here, we use a beamforming. So we're not going to transmit to everybody. I want to transmit to X, Y, Z, and I will send my beam here. And there is some artificial intelligence here. Maybe deep neural network. This is something we are interested in. Look, this is what we call it massive MIMO. You have here 1, 2, 3, 4, 10 by 10. This is 100 antenna. So I could put here 100 antenna now. I can't put now 100 antenna. I could put a few of them. But I could put now 100 antenna if I would be able to use this gigahertz. And then I will have my antenna even smaller than 1 pence. This is British 1 pence, okay? Look, this one and this one, okay? This is what we are working on it. Okay, this is what we are working on now at this moment. And this is definitely 6G. This is another work which we have done it, and this is a case bed. We have 240 server. We put it in our lab, and then this work has been used a virtualization of SDN. I don't want to go into details, and LV in the cloud. So we have a cloud. We have some work here, and we developed new protocols. And this work has been published in IEEE ACM Transaction on Networking in year 2018. Sorry?
If I may interrupt you, we have about 30 minutes and then we have to allow for more.
Okay, I will skip. Okay, I will go quickly now, slide by slide. This is because this is very interesting about wind turbine, and we have been able to do this work. If you look, this is what we have done in the lab. I think Steve and Talal knows where is this. This is in Brunel, honestly in Brunel. Yes, Steve? So this is in Brunel, and this is what we have done. And this work has been published in IEEE Access Journal again in 2018. This is tactile. I'm going to skip it. This is something about proposed technical description of a system where we used Hadoop with the cloud, with the big data. Again, this has been published in IEEE in 18. This is another one where we have a sensor to sense, different sensor to sense what is the problem with the solar energy. Again, this has been published in IEEE Sensor Journal. This is about the gateway and SDN. This is how to have energy efficient with the cloud. And this is about big data. If you look to this one with the big data, this one here, again has been published regarding different kind of sensor, has been published in IEEE Sensor Journal. This will show you how we have developed a new protocol, and you see how much this is difference between this one here. There is about 2,000 rounds, which means this is how long the sensor will last, because the worst case scenario, you need to change sensor from time to time. This will cost a lot of money. Why this is happening then? This is our publication. If you look here, most of those publications are IEEE. Okay, and this is only, I haven't put all the publication. This is only for year 18 and 17. So those are all our publications in 2017 and 18. And then this is okay. Right. Now I will come to wireless, MSc wireless communication. I'm not the course director for this one, but I do teach 2 modules on this. But I might be a course director for your course here. Now what we have 8 modules with the project. And if you look here, those are the 8 modules. Each one has 15 credit, and we have a project here with 16 credit. If you look here, those are the topics. Wireless communication networks, this one I do teach it. A research method and professional development, I do teach this one. And the radio and optical communication system, somebody else, and communication network security. So we have security, and we have the research method, and we have a wireless, we have a project and control management. This will deal with the project, how to collaborate as a team, how you look to the customers, and so on. We have DSP for communication, we have networking design and management, and advanced digital communication, and then the project. Now the project, some of our students go to different companies, and some of our students, they stay at university, they do their project, whether it is hardware or software. Let me talk about wireless network technology, which is the one that I do teach in communication. This is the topic. If you look here, UMTS 3G, 4G, 5G, other communication technology. I would like to give the student the most important thing is connectivity. If you have devices, how you connect this to the internet, to the other device, to the human being, and so on. We have Zigbee, UWB, Bluetooth, ad hoc, and mesh networks. And every year, we try to cut something here, 10%, and add new topics here, and so on. I could tell you, 10 years ago, I haven't got this one and this one. And then I was teaching this into more details. But then I added gradually 4G, and then after that 5G, and so on. And it will come time, I don't know if I am available, then there is no UMTS, because I think within the next 10 years, maybe there will be no 3G. Okay? This is one of the topics. The other topic is radio and optical communication, and this will teach both fiber and radio with the satellite, and those are the main topics: optical fiber, light propagation, optical sources, WDM, wave division, multiplexing, and optical networks. The other one is project and dissertation. This is where the student, as I said, they do the project either in a company or in the university. And mainly, most of our project is to the age of technology. And this will start because our course will start in September, late September, and then by May, the exam, and 1st of June, the student will start their own work, and then by end of September, they submit their thesis. So June, July, August, and September, 4 months for their project, and then that's it. Research method and professional development. We teach the student how to carry on research, how we going to go and do some investigation, how to write a proposal, how to write a paper, all this, how to give a presentation, okay? All this we teach it in this topic, and I share this with another member of staff. He took 20%, I took 80% of this, and then if you look here, those are some of the topics, and we change this from here to another. If you look here, this is multi-tenant agency, cloudification, virtualization, open flows, security for IoT, beamforming for millimeter wave, big data with AI. All this, if you look here, those are topics. We give it to the student and we say, okay, go, and we haven't taught this. We haven't taught this. We give them those topics and go and investigate. Each student will choose one of those, will choose only one. And then they go and do a case study, and this is individual case study. In the meantime, and there is no exam for this topic, they will get 40%, another 40% where I do teach it as well, called the group project. Each 2-3 students, maybe sometimes 4, depends on the size of the class, they do one group project. The idea behind it is to teach the student how to cooperate, how they deal with each other, how they do the presentation, and then, by the way, both of those case study, individually and the group project, the student give a presentation. And with the group, we'll bring all the 4 students, and 4 of them, they will give the presentation as well, okay? But but they will do a great job and they will learn a lot of things. And then by the end of the project, we share all the PowerPoint between them, so all the students will have a lot of material, they will be educate themselves, and this will prepare them for the MSc project as well. And I found this is, the student, they like it very much. And they go and investigate their own way, and they spend some time with this type of case study. Communication network security, they teach all the topics in the security, like this encryption, Wi-Fi security, and authentication, security engineering, all these things in this security. There is another thing called the project and control management, and this will teach the student how to put teamwork at the core of any project and ensure that the voice of customers is embedded throughout the monitoring process. And this is something which is taught by somebody who is expert in this area. Maybe he is not wireless communication expert, but he is expert in the project and control management. DSP for communication, then this is the topics. It is implementation of DSP algorithm, different kind of algorithm, FFT, whatever, and DSP hardware and software, and there is a lab as well with this module. Network design and management, the aim of this module is to introduce a model and algorithm with network design, and those are the topics, okay, which is required some of knowledge in background in networking, because there is network function virtualization, there is SDN, and all the required things for the network, quality of service, quality of experience, and then advanced digital communication, which is they will teach all the communication aspect for digital, like source coding, channel coding, modulation scheme, propagation, whatever, MIMO system, and so on. Thank you very much.